Robot manipulator is a vital role of robotic system to maintain the accuracy and repeatability of robotic arm. To control a robotic arm is still hassle and time consuming in many industrial sections. The project aims to provide a simple yet intuitive approach towards training the robotic arm. Apart from pick and place with a simple pre-defined instructions from the user, the trained robotic arm will be able to autonomously choose a particular instrument among different other objects and organize them in a specified order as required by the user for a particular event. The system has a 3D printed robotic arm parts connected using a two different type of servo motor based on their torque requirement. This robot arm can be wirelessly controlled and programmed using a custom-built Android application. Using the buttons in the app, we can manually control the movement of each servo or axis of the robot arm. Also, using the save button, we can record each position or step, and then the robot arm can automatically run and repeat these steps. With the same button, we can pause the automatic operation as well as reset or delete all steps so that we can record new ones. This way the user will be able to easily configure the robotic arm and subject it to any appropriate activity the user desires, all this while keeping the user interface and understandability simple. SolidWorks 3D modeling software was used to build the robot arm. There are 5 degrees of freedom in the arm. We used the MG996R servos for the first 3 axes, the waist, back, and elbow, and the smaller SG90 micro servos for the other 2 axes, wrist roll and wrist pitch, as well as the gripper. We are now able to assemble the robot arm after receiving all of the 3D printed parts. A custom-built Android framework can be used to monitor and program this robot arm wirelessly. The Android application will provide the Arduino with the appropriate angle for the servo motor to turn to the user's desired location, allowing the user to control the end effector of the robotic arm as he wishes. Connecting the electronics is the next step. For contact with the smartphone, all we need is an Arduino board and an HC05 Bluetooth module. 6 digital pins on the Arduino board are wired to the control pins of the 6 servo motors. We'll need 5 volts to power the servos, but this will have to come from somewhere else because the Arduino won't be able to handle the current that they all draw. At least 2A of current must be handled by the power source. So, once we've linked everything, we'll be able to program the Arduino and create the Android app. The MIT App Inventor online technology was used to build the Android app. It consists of simple buttons with suitable background pictures. Everything in this project is being designed with a motive to make the manipulation of this robot as simple as it can for the end user. Most of the things that we have considered using in this project definitely has an alternate such as move it rather than MATLAB. We considered this because it has an added advantage that the forward and inverse kinematics is calculated by itself and does not require us to calibrate the initial and final positions of the robotic arm.